So let's jot down some notes. This is section 8.5, Algebra 1, using distributed property. I don't even like that title. Let's call it factoring. Factoring. And then you could say using distributed property, but I still don't like that. It's section 8.5. It's called factoring. And what we need to really understand is what factoring is. What is factoring? Factoring a polynomial is to find the factors that will multiply to the polynomial, or to give the polynomial. I don't even like this definition either. All right? So, I say factoring. What is factoring? Write this down, guys. Factoring is simply distributed property but done backwards. Okay? Factoring is distributed property but done backwards. Now, what do I mean by that? Well, let's first think about what distributed property is. What is distributed property? Let's say I had a 3x squared times 2x plus 5. If I were to distribute, what would my answer be? Whoops. 6x cubed plus 15x squared. You guys agree with that distribution problem, right? And that answer, right? Yes. So, according to my definition, factoring is simply distributed property but done backwards. So here's distributed property, here's our answer. Factoring is when they give you the answer and they want you to go back to this situation. All right? So it's kind of like this. Let me zoom in on this. It says, let's say that the instructions right here said factor. Factor. Factor what? Factor 6x cubed plus 15x squared. Now let me show you how to go about that. To factor 16x or 6x cubed plus 15x squared, you got to look at your terms. How many terms are there? There's 2. And you got to see what's in common. You got to see what's in common. So the coefficient 6 and the coefficient 5, do they have something in common? Do they have a multiple in common? The number 3, the multiple 3. So I am going to be able to pull out a 3 from the binomial. Not only am I going to be able to pull out a 3, but I'm also able to pull out x's, because there's also x's in the first term and x's in the second term, and you want to pull out x's. It's not enough to just say you're going to pull out an x. See, what you want to do is pull out the greatest amount of x's. So there's 3 x's here, but there's only 2 x's here. What's the greatest amount you could pull out from both at the same time? 2. Does that make sense? Now, if you think about it this way, okay, you're probably thinking, oh, 3. Yeah, you could pull out x to the third from here, but could you pull out 3 x's from here? No, there's only 2 of them there. So what's the greatest amount of x's you could pull out from both of them at the same time? That would be an x squared. Does that make sense? Okay, once again, guys, right here there's 3 x's. Right here there's only 2 x's. So what's the greatest amount of x's that you could pull out? You can't pull out 5 from here because there's only 3 of them. You can't pull out 5 from over here because there's only 2 of them. Could you pull out 1x from here and 1x from there? Yeah, you can pull out 1x, but that's not the greatest factor. The greatest amount of x's you could pull out from here, and here is 2 x's at the same time. So that's why I pulled out an x squared. Does that make sense? Yeah. All right, so this guy out here, this guy right here that we just pulled out, that's called the GCF. That's called the greatest common factor. And we'll get to the vocabs right now in a little bit. But that what we pulled out right now, that's the GCF, the greatest common factor. And what is greatest common factor really? It's what's in common, the greatest thing that's in common in all your terms. So right here you have 2 terms. The greatest thing in common in both of these is the coefficient 3 and also x squared. That's the greatest common factor. Now, like I said, factoring is really a reverse distributive property. So if I had 3x squared times what? What does this first term have to be? 3x squared times what will give me a 6x cubed? A positive 2, because 3 times 2 gives me the 6, and an x, because x squared times x. Again, x squared times x gets me back to the x cubed. So do you see how we got this first term 2x right there? Okay. Now, how about the next term? if I say 3x squared times what will give me this new 15x squared that we had up there? That would be a positive 5. No x's. So ladies and gentlemen, this is what we call factoring, where you have a polynomial, in this case a cubic binomial, and we looked at both terms, we found the GCF, and we pulled out the GCF, and this is what we have left over after pulling out the GCF. Does that make sense? Okay, now of course we're going to practice a lot more of this stuff. So going out here, back to our original page of notes, the GCF is the greatest common factor. Okay, so let's take a look at this first polynomial, ignoring the factored form that's already given to us right there on those notes. So if I asked you, what is the GCF right here? Let's think about this. Let's look at the coefficient only, 27 and 18. Do you have a multiple of 2 in common? In other words, could I divide both of these numbers by 2? No. How about by 3? Yeah, 3. So 3 might work. Is there any other number that's greater than 3 that might work for both 18 and 27? 9. Right? So it's not enough to just say, oh, 3's in common, I'm going to pull out a 3. You could do that, but it's going to take you a lot longer. What you need to look for is the greatest common factor. So 9 is the greatest. Now, what would be left over? Oh, no, wait. Before we move on to what would be left over, in addition to the number 9 working for the 27 and the 18, I'm pulling it out, we also have y's here and a y right there. So how many y's could I pull out from both of them at the same time? Only one y. So the GCF is really 9y. That is a y, it looks like a 4, I'm sorry. 9y, that's the GCF. Are you following me? Okay, so now what would be left on the inside? If I pulled out a 9y from here, if I pulled it out, what would be left in there? Think about this. 9y times what will take you back to the 27y squared?
3.
That would be a 3 with the y. Now you could think of it a piece at a time. What's 9 times what will get you 27? 9 times 3 will get you 27. How about the y's? Y times what will get you y squared? Y times y will get you y squared. Make sense? How about this other term over here? If I did pull out from the 18y, if I pulled out the 9y, what would be left? In other words, 9y times what will get me back to the 18y? Positive 2. Right? Because 9 times 2 is 18, and y times, there is no y, that'd just be a y up there, so perfect. That's what we call factoring, guys. Especially factoring out this guy, which is called the GCF. GCF, the greatest common factor. Now, on our notes, they show us the polynomial, and then they show us the factored form. By the way, this is called a factor, that's called a factor, so that's why they refer to it as factors. All right? Let's take a look at this one down here. It's a little more entertaining. That's a quadratic trinomial with 2 variables, a's and b's. So let's take a look at all 3 terms, 1, 2, 3, and let's pull out the GCF. What is in common in all 3 terms? And let's first start with the coefficients. -4, -8, +2. What could I pull out? I could pull out a 2. Bless you. Okay, that wasn't funny. If you pull out a 2 out here, is there any letters that are in common in each and every term? A and B. So if I focus in on the A's, how many A's are here? There's 2. How about here? 1. Here? 1. So how many A's could I pull out from here, here, and here all at the same time? Only 1 A. Only 1 A. So you're going to pull out an A. You know what? Let me, I'll squeeze it in there. Okay, now how about the B's? How many B's do we have? We have 1 B. We have 2 here and 1 here. But what's the greatest amount I could pull out from all 3 of them at the same time? 1. So you have a 2AB, and that is what we call the GCF on this one. The 2AB is the GCF. And now we could think about what would be left over if I did pull out the 2AB. What's going to be left over in here? You're going to go, or you're going to think, 2AB times what will give me this first term? Now, it's as easy as this. You don't have to think of the whole thing. Think of it as a piece at a time. How about 2 times what gets us that -4 in front? A -2, right? And now how about the A? A times what gets us an A squared? A, okay, so let's put the A right there. And finally, B. B times what will get us a B? It's just a B, right? Yeah. So you don't have to worry about it. That's your first term inside the parentheses. Now let's go to the next one. I'm sorry, hold on. 2AB times what will get us a negative 8AB squared? Think of it one piece at a time. 2 times what gets us a negative 8? 4. Negative 4. And then how about A times what gets us an A? You don't need anything, right? So A times 1 gets us an A. It'd be kind of ridiculous to put a times 1 because 4 times 1 is still 4. So you don't have to put the times 1. Just don't put anything. But then you move on to the B. B times what will get us a B squared? B. So all you got to put as your middle term is negative 4B, minus 4B. Now for the last term, let's start with 2 times what will get us that positive 2? And let's put a plus 1 since it's positive 1. And moving on, how about A times what will give us an A? Nothing. B times what will give us a B? Nothing. So technically you could put times 1, but that'd be just 1 at the end of it all. So ladies and gentlemen, this is your factored form. The 2AB, that's your GCF. It's your GCF. Your remaining polynomial is negative 2A minus 4B plus 1. Of course, the notes, they had it shown right here. I just wanted to explain that whole thing for you. That's how the GCF 2AB came out, and the 2A, negative 2A minus 4B plus 1 was left over. That's what we had down here. So we need to start practicing right here. Let's factor. And another way of thinking of this is factor out the GCF. Always try to find what's in common so you could pull it out. So let's check this one out. Let me ask you guys, what's in common? What could we pull out? You could definitely pull out a 5. Could you pull out some X's? No. Why not? Because, yeah, there's X's here. Is there X's over here? No, there's Y's. Well, could you pull out Y's from both terms? No, you can't. So the only thing that's in common, is a 5. So if you did pull out a 5, what would be left in there? In other words, 5 times what will take you back to the 15x squared? 3x squared. And then over here, 5 times what will take you back to the plus 10y? Plus 2y. And ladies and gentlemen, that's factored. That's it. Now, don't think that you're always going to be able to factor. Sometimes you can't factor. Sometimes there's just nothing in common. And that's where, like, let's say I had this one. This is not even on the worksheet here. But let's say I had 7x to the third minus 5y. I'm making this up, by the way, plus 2. And if I were to say factor that guy, well, is there a number in common with the 7, the 5, and the 2? No. Is there x's in common? Well, there's an x here, but there's no x here, no x there. Is there y's in common? No, no y's. So there's absolutely no common term. There is nothing in common that you could pull out. So there is no GCF. So right there you would just say not factorable. And that exactly means that you're not able to factor. Okay, not able to factor. It's not factorable. That happens sometimes. Let's check out this problem over here. Could you guys factor this one for me? Okay, let me ask this. What's the greatest common factor? It's not just 2, but there's also the letter C. So 2C is the greatest common factor. If you did pull out a 2C from in there, what would be left? 7C plus 1. Right? 2C times 7C gives you that. 2C times 1 gives you that. We're done. Next one. What's in common there? 10. Absolutely. Right? But there's something... Is there something greater in common? No, 10's the greatest. Okay, so 10. Is there anything else besides 10? X squared. There is no V's, but there is X's in both, and the greatest amount would be X squared. That's a GCF. What would be left on the inside? 3V plus 5X. Done. And ladies and gentlemen, that's how we factor. Okay? We're going to pick this up on the next video.